Hey there guys, my name is Clement from The Graphic, and in this video I'm going to be showing you guys all you need to know about unit testing with Jest. So if you like this type of content, please do not forget to leave a like and subscribe because that really helps this channel and I really appreciate all the support I've been getting recently in these videos. So without any further ado, let's get on with the video. So before we start talking about unit testing with Jest, what is Jest and why are we using Jest for our applications? Well, Jest is a library that's used to automate testing, and of course, you regularly test your code by just pressing buttons and running functions. But in the real world, when your application starts getting really large, that is really not enough. You need to automate this workflow of testing your code in such a way that your code will be less prone to errors. And when you add new features, the previous feature you added will still be tested in an automatic manner, right? So that's why Jest is so important. Jest helps you to test your code automatically using code, and it also helps you write better code as a result of that. So we're going to be going into more on Jest on this course. We're going to be exploring as much functions and as much assertions as possible. So it's basically before we move into the coding part of Jest, let's talk more about these automated tests because there are different types of tests in the software engineering industry. In this video, we're going to be covering unit testing, but let's just check out all the different types of tests there are. This is just one slide. I'm not going to go more than this slide. We'll get to the coding part soon. So basically, it's important to understand what unit test is and what unit test is not. Basically, unit testing involves writing automated code that tests individual functions, right? You're not going to be testing two or more functions together in one unit test because that does not make sense. The whole point of unit testing is to test in every single individual function that makes up your entire business logic. The theory is if you test all these individual functions that make up your entire business logic, then your system is pretty much battle ready and foolproof, and you need to just do minimal personal testing, manual testing, to move on with your application before you deploy it to production. But basically, the automated tests, if you write really good tests, you really don't need to do much manual testing, if at all, right? But there are different types of tests that we recommend that you do. So this is just one type of test, which involves testing individual functions. The other type of test is integration testing. And basically, there are some functions that use other functions that are integrated with other functions. It's also important to test these integrated functions. Like there's some functions that you can write that have 2, 3, 4, or even 10 other functions integrated in its whole core. And to be sure that it gives the right value after passing through all these functions, it's important to test these integrated functions together. We're not going to be going too much into integrated testing in this particular video, but it's something that we'll be looking to talk about in a future video. Yeah, so there's the final type of testing, and this final type of testing is called end-to-end testing. This basically involves testing your entire software, your entire workflow, and just by using specialized software like Puppeteer.js, or I think Truffle as well. Yeah, so basically I use Puppeteer.js most of the time. So Puppeteer.js along with Jest. And we won't be doing that in this video, but the whole point is to test your entire software or like completed major modules of your software by having a headless bot, in this case of Puppeteer, a headless Chrome bot crawling through the pages and clicking buttons, and then using Jest to say, this element is visible on your screen, or this text is visible on your screen. And that's basically the entire process of end-to-end testing. Again, we won't be discussing this in this video. We'll only be focusing on unit testing. Awesome. So let's move on to the code. And as I said before, we are going to be using Jest. So there's a lot of cool things in the Jest website. So you can go to jestjs.io. And if I think I didn't state this earlier, Jest is a JavaScript testing framework. It's built for JavaScript. So there are certain, obviously you have to have some knowledge of JavaScript as well for this course. And you can look through the docs by clicking the docs button here. I'll leave the link in the description below. And the docs is like very, very exhaustive. You can go through this in your time, but I'll cover as much of the content here as possible and try to be as explanatory as possible. You also need to have nodejs.org installed on your screen, on your computer. This is you need this software to actually run Jest on your computer. So, get this installed and, let's move ahead. I am also using Visual Studio Code for my programming processes. So be sure to go to code.visualstudio.com to download Visual Studio Code so that you can follow along with the tutorial. Awesome. So let's start the coding finally. Okay, as you can see here, I have an empty workspace on my Visual Studio Code file. And if you're using Visual Studio Code, you can just go to the bottom here and drag this terminal here from the bottom, or you can press, if you're on the Mac, or I think this is for every PC, you hold Control and you press the backtick button to bring up this terminal as well. Awesome. So I want to type some code in the terminal. Note I have an empty Jest folder. I call this folder Jest. YouTube, you can call it whatever you want, but this is just an empty folder. Then I'm going to install my npm package first, because Jest uses npm, as I said before. So I'm going to type in npm, and npm comes in with nodejs as well. So npm install, or in this case npm init, because I need to initialize my npm project. So to answer yes to all the questions, I'll just put -y. So I have initialized my npm project, and now my package.json has been created. Right? Awesome. So the next thing I want to do is I want to install Jest, right? And since Jest is a development dependency, I need to install it as a dev dependency, so as not to bloat up my production dependencies. Awesome. So I just type in npm install --save -dev, then I type in Jest. Wait for a couple seconds for this to install. Okay, now Jest just finished installing. The next step is, let's start writing our tests with Jest. And as I said, Jest is just used to test different parts of your application or different logic of your application. So we're gonna go right into the code, and that way it's become clearer as I type the code. So to make my code organized, I'm just gonna create a new folder. You don't need to do this, but I'm gonna create a new folder where I keep all my tests. So I call this folder tests. You can call this whatever you want to call it. Then I'm going to create my first test file. So to create this test file, there are a few rules, but it's not a big deal actually. So basically, to create a test file, you can call the first part of the file name whatever you want to call it. In this case, I'm going to call this my first test. And then let me just write this in camel case. My first test, right? So then you need to say .test .js. Or you could also say .spec.js. Either of these work, but I'm just gonna change this to .test.js because I think that makes more sense for newcomers. So my first test.test.js. Awesome. So I have my first test file, which is really cool. So how do I write my tests? So I'm gonna write a very simple test. But before I write that test, I want to include Jest in my package.json testing scripts. So to actually make everything work with Jest, I'll just come in here, this test text that is here. I'm gonna clear it away, and then I'm just gonna write something really simple, Jest, so that when I write in my terminal npm run test or npm test, it can then initialize the Jest package that then watches every file that is named with .test or .spec.js. It watches every file and runs every test that is written in those files. Awesome. So now that I am in my test file, I want to then write some tests. The first thing to do when you're writing a test is just to say, well, you guessed it, test. You don't need to import anything. Test, and this test is a function that takes in the description of the test and another anonymous function that executes said test. So in this case, I want to write a test, a very simple test that says 1 plus 1 should be equal to 2, right? This is a very simple test. You won't be doing this in production, but I'm just trying to, just trying to ease you guys in. But it's a very simple test, and you can write whatever you want to write here. This is purely your choice. It's just describing to you and your other developers what this particular test is trying to look out for. So how do we test, for example, that 1 plus 1 is equal to 2? Well, there's this function that Jest provides called expect. And what expect does is expect takes in the logic that you're trying to compare. And in this situation, let's say our logic says this. Let's say our logic, before I write the expect, let me write some regular JavaScript. A equals to 1 and let B equal to 2. So equal to 1, I mean, and these are two variables. So I want to expect, or I should expect, A plus B to be 2, right? So there's a method called to be, and I should expect it to be 2. Perfect. So this is actually our first test. Now let me explain what's going on here. This expect function takes in an expression or a function that returns something. And when this expect, when the logic, when the parameter is accepted in expect and expect runs, it returns an expectation object. And this object can then be compared using certain methods, which I'll go through with you, compared to other values in JavaScript. In this case, we have 2, so we expect A plus B to be 2, right? And we expect this test to pass because 1 plus 1 is indeed 2. So enough talk. Let me then show you how I run this test to be sure that 1 plus 1 is 2. So let me just clear my console real quick. Then I want to run npm test. I can do this because I already set my test scripts to run Jest, which looks for all files named .test.js by default. So I'm going to run this. It's going to look for all files, and then you can see that there are a couple of things that are printed in our console before the process exits. the first thing is it runs Jest, of course, and then it finds that there's a test file that is named .test.js, and there's one test inside of this test file. And this test is called 1 plus 1 should be equal to 2. And we see that the test passed because it says one test suit passed, one test passed, and there's one test in the file in total because there's only one test running in this file. So it's there are a couple other properties here, snapshots, time, not really too important, but the most important part is our test passed, because generally we expect 1 plus 1 to be 2. But let's say for some reason in your application this becomes 5, right? And we save this. Let's run the function, let's run npm test again. You can see that something different gets printed in our console right now, and we see this big red fail. Well, do not be scared about this big red fail. It's just telling you that there's a problem with your logic, your test. And let's just read every line, line by line, to understand what's going on here. So it says that the test failed at a test called 1 plus 1 should be equal to 2. So then it points us to the line where this happens. It says it's expected, there's an error between the received and the expected, that it's received something different from what is expected. And we can see that in this line here, in this highlighted line here, it's expected 2 because our test expected a plus b to be equal to 2, but it received 6 because 1 plus 5 is actually equal to 6. And then it pointed us here to the exact point of the code where the error originated from. This is very helpful. This way we can know what happens and why our code is actually failing. And this is very helpful for us to understand, the logical flaws in our code. Awesome. So now we have written our first successful test and our first not successful test. And we actually don't want to write not successful tests, so I'll put this back to 1. And so I don't keep needing to run npm test every time I write a test, there's a very cool helper argument you can add to Jest. You can call this --watch all, so that it watches every time there's a change in any of these test files or any JS file in general. So --watch all watches all your test files. So let me save this and then run npm test. And you can see now it's watching every time that there's actually a test running. It's actually watching anytime we actually save the test, it's actually watching for every file. So if I press Ctrl S, you can see that the test runs again. Cool. So let's run some other tests, shall we? Just to get used to it. So I'm gonna run another test now. I can run multiple tests on the same file, and I can say I expect 5. I want 5 plus 5. I want to test that 5 plus 5. 5 plus 6 is not equal to 10. So how do we test for non-equality, right? Again, I'm going to say let a equals to 5, let b equal to 6. Then I say expect a plus b. In this case, instead of saying to be, I'll say not to be. That's pretty much Shakespeare. So expect a plus b not to be 10, because we know that a plus b shouldn't be 10. It should never be 10, right? This is 5 plus 6. It's not 10. So this is 11. So if I save this, you see that the test passed, and I see one test suite. This test suite just basically means this test file. And the test, there are 2 tests that have passed now. But let's say I make this 10, 11, which is what it should be, but I'm testing that it should not be 11. If I save this, you see that I have the same error we had before. So I get one test failed, but this first test still passed. Awesome. I'm just going to revert this back. And you don't really need to create a new test block to test some to create a new expectation. You can have multiple expectations in the same test. You can expect this to be 2 again and save, but it's still one test getting passed, right? But most times I like to always have an expectation on just one expectation per test, right? I prefer having this instead of having multiple expectations on one test, because I feel like it's less organized this way, and you can there's a probability that you may not be able to easily track down the problem. Although this is just my opinion, you can definitely do this in yours, but I rather do this. But there are better ways to even organize these tests further, because you'll be writing probably thousands of tests. You like to group them properly in terms of the type of test you're writing. So there's something called the describe block, and this describe block is much like the test block, but it describes the whole tests as a whole, so that you can then know what is being tested properly in the logs that follow in the terminal. So the describe block takes in a description first of all, and I'm just going to say number operations just to describe all what I've been doing so far. These are number operations, and this takes in a function, of course, that runs all of these tests. And I'm just going to move this test. Just going to cut it and put it in here. Oops, what am I doing? Just paste this in here. Then I'm just going to remove this one. Awesome. So let me just clear the console. The process died for whatever reason. It's going to run npm test again. So you can see now that I get this header called number operations in my console, and then under number operations, which is the main block that describes the list of operations I've been doing, then I have the tests that follow. Awesome. So we're making real good progress with Jest, testing different operations and different stuff. I want to go a little deeper in testing, more matchers, right? So and this to be and not to be, all these methods that follow here, this to be method, they're called matchers, and there are many more matchers. So I'm going to create another describe block just to cover a couple more of these matchers. So I'm going to create a describe block saying describe testing other matchers, or matcher methods to be more descriptive. So I'm going to write a test here. Just follow along with me. I'm going to test for undefined, right? I'm going to write some tests on undefined, the value undefined. So I'm going to testing for testing that a variable is undefined. And there are many ways to test that a variable is undefined, right? And this is where it makes sense to write many expect expressions, right? So let me say let number is equal to undefined, for example, right? So the first thing I can expect of this, I can say expect. Let's say we don't know what this number is. Maybe this is a function, and we're looking to bring in functions in our test file. But let's say there's a function that returns undefined, and we want to test that this number actually is undefined. So we want to expect that number, in this case, is not to be defined. This is one way of expecting a number to be undefined, not to be defined. Another way is to say expect that the number is to be undefined, right? This is another way to test that this number is not defined. So these two do the exact same thing. If you want to be thorough, you can also test that the number, even though it's undefined, it is not null, right? So we expect this number to not to be null, right? We know that it's undefined, but in JavaScript, undefined is not truly equal to null, right? There's another thing we can test. We know that the Boolean equivalent of undefined is actually false, so we can expect this number to be falsy. This is another term to check the Boolean equivalent of certain numbers. Like if we have undefined or we have null, we expect those to be falsy. We also expect, this is the final check, I promise, expect the number to not be truthy. Not to be, rather, truthy. Awesome. So we expect all these tests to pass because this is the definition basically of undefined. It's not defined. It is undefined. It is not null. It is falsy by Boolean expression equivalents, and it is not truthy because the same thing. These two mean the exact same thing. This highlighted to the last two here mean the exact same thing. So let's save this and check it out. You can see that we have our third test passing now, and that test is called testing other matcha methods, testing that a variable is undefined. To make this more descriptive in my test, you can say something like testing that undefined is not defined, not null, undefined, not truthy, and falsy. But I won't go into changing the description of the test. You can do that on your own, depending on what makes sense to you. I'm also gonna, before I test for other things, if I change it to null, you see that this test doesn't pass because the number is null, but the number is actually defined, right? So this is the first expectation expression that will fail. The number is actually defined, even though it's null, it's defined. And these two are gonna fail, but what happens generally is when the first expectation fails, it doesn't move on to the next because it doesn't make sense to move on to the next. So this is gonna fail, this is gonna fail, this is gonna fail because it's actually null, this is gonna pass because null is falsy, and this is going to pass because null is not truthy, right? But it's not even gonna hit any of these lines because it's gonna fail at line 25. Let's test that to see. Awesome. So you see it actually did fail at line 25. That's why it says here we pointed at this line and it terminated the function at this line. So it receives null, and we expected it to not be defined, so it doesn't make sense. So let's take this back to undefined. So basically we're testing that undefined actually is in line with all these matcher methods. Awesome. Let's try and move a little faster. We have a couple more to cover. So if we want to test for, let's say we're testing for 0. So we're testing write tests. And another way to write this test function here is to write it. It's pretty weird, but it kind of like makes sense if you form your test like this. It should expect 0 to act like 0 or whatever. We can write our test like this. If I say test, it does the same thing as it. It's really not different. It's just an alternate way of writing tests, but I'm going to stick with test. Then I can expect, I can just maybe copy the exact same thing here, or not really, I'll write it from scratch. I'll say let number is equal to 0 in this case. And what do I expect 0 to be? I expect number, right, to be defined, right? I know it's defined. I know that it is not undefined. And let's save this as we go. Not to be undefined. I know that the number is not null. I know that the number is falsy, not to falsy. And I know that the number, of course, is not to be truthy as well. Awesome. So this basically is 0 because we know that 0 is defined. If we put not here, the test is going to fail. So this all makes sense that it's like this, right? Awesome. So there are more matchers, there are more operations that we can do. This is just gonna be the final one on numbers, hopefully. I've done a lot of numbers and undefined and all. I want to move on to the arrays soon, and then to bringing in functions. But let me just write this one on number comparison. In this case, I'm going to test for number comparison, and for number comparison, there are like just a handful of matchers for number comparison. And this, sometimes you want to test whether a number is greater than or equals, or just within like less than or whatever. So for number comparison, we already covered some of these when we used to be, but I just want to cover a little bit more. So I can say const value is equal to, or let me say const number is equal to 1, and or const a is equal to 1, const b is equal to 2, right? I expect, if I want to say like I want this number to be greater than 2, so I expect a plus b in this case to be greater than 2, right? I know this is gonna pass, right? You can see a number comparison passed because 1 plus 2 is indeed greater than 2. I also expect this a plus b, of course. So let me just, to be faster, let me just copy this line and change the method. I also expect this to be greater than or equal to 3, I think. Is greater than or equal to 3, definitely. If I save this, it's passed because it's actually equal to 3, so it's greater than or equal to 3. I expect this to be less than 10, because 1 plus 2 is actually less than 10, right? So I also expect, yeah, I think this is pretty much it in terms of, I think there's less than or equal to, yeah, that's the final one. So I expect this to be less than or equal to 2. Oh, I think that's wrong. 1 plus 2 is 3, so it should be it's less than or equal to 5. This makes sense. Oh, awesome. This comparison could be a little bit confusing, but you get the point. We can use greater than or greater than or equal to all the things that we know how to do in programming to test for ranges, sort of. Awesome. So we've done a lot of numbers, and also let's move on to testing for like strings and string matches. Then we'll move on to arrays. I'll be really quick about this, so let me just quickly test for strings. So test let me see, there's a cool test I can give here. There's like a regular expression sort of test, but not really so in depth in regular expressions. So I'm gonna test that there should be no I in team, for example. In this case, we can expect, let's say, let string value here is equal to team, and we expect that string should not to match. This is another new one we've not seen before. To match. And what toMatch takes, it takes either a string or a regular expression. In this case, we can use a regular expression called I, right? And basically, because we're checking that there is no I in team, we want to be sure that there is no I in team, and definitely there is no I in team, so this should pass. So awesome, you see that there should be no I in team. It's one of the tests that have passed here, But what happens when we put I in team, right? You see that the test fails, obviously, because expected pattern, not I, and received string that had I, and you can see that it actually highlighted this in red because the string literally had I. So you can see how powerful this can be when you're doing some string manipulation or regular expression manipulation, for example. This can be as complex as possible. In this case now, if I put small letter I don't think it'll work because it's expecting capital letter I, right? So basically, it's gonna miss out on this I, but one way to avoid it missing out on this I is to add another term here. This is not a regular expression class, but I can add this term called I here, which indicates case insensitive. So if I save this, you can see that it actually caught this I that was here because this I put here means case insensitive. So I'm just telling you that you can really get really complex with regular expressions. So I'm just going to leave it as this and move this I here. So there is no I in team, right? Which makes sense. Awesome. So you could also say something like, let me just repeat this now to be quick and change the text here to say there is stop in Christopher, because there's actually a stop in Christopher. So I say expect, in this case I'll say Christopher to match, because I want to match something here. I'm going to match stop because I know that there is stop in Christopher. So awesome. So there is stop in Christopher passed as well. And note, if I put capital letter P here, this will probably fail because we didn't match case insensitive terms. So be careful with this. It doesn't check for case and it checks for case strictly. If there's a capital letter P here, it won't pass if you don't pass in the capital letter P here as well, or you can just pass in this I for case insensitivity. So this way it's gonna accept this P regardless. Okay, cool. Let's move a little faster now. We have tested strings and this works, right? Then I want to also test a really quick test on arrays as well. So testing arrays, I'll come here and say test. Let's say I have a shopping list, and I can write things above the test as well, or a shopping list of maybe milk, trash bags, paper towels, or whatever, toilet, or I don't know, iPhones or whatever. And this is my shopping list, right? Then I can test that the shopping list doesn't have PS4, right? For example, or has PS4 or whatever. If I'm gonna test for this, I can simply say I can expect my shopping list in this case to not to contain, in this case, PlayStation 4, right? So if I save this, I see that the test passed because it indeed does not contain PS4. But what should happen when I add PS4 to the mix here? You can see that it fails because it actually does contain PS4. It receives the array that contains PS4, and then this doesn't make sense. Then I can also check that it contains milk in it, and it contains milk. Now let's check whether this is actually case insensitive. You can see that it is not case insensitive, that it should actually match with everything that is in this array exactly. So yeah, it should be milk with capital letter M. Awesome. So this is just about arrays. There are more things to cover with arrays. Um, there's one more thing I want to test with regards to reference and primitive type equality. Basically, this is done an in-depth JavaScript class, but primitive types, there are two different types of types in programming languages, not just JavaScript. There are primitive types and there are reference types, right? So reference and primitive types have their own special meaning. I won't get too deeply into that in this video, but long story short, we can't say this is equal to this because an array is a primitive type and this two have the way they are stored in our hardware system. But there are ways to compare array and object equality using a testing library like Jest. So let me just write a new describe block here and say, let me just even write a comment, testing primitive and reference type equality. So what I've been doing so far is actually testing primitive type equality, because numbers, strings, booleans, those are all primitive types, right? Then the reference types are arrays, right, and objects in JavaScript. So let's just say in this describe block that we are testing reference equality. Awesome. So now we're testing reference equality. Let me quickly correct this function. We can see that let's write something, right? Let's write a test. So let's say I have an object, right? A user object in this case, and the user's name is my name, Clement. And then in the course of operation in your software, your system, you say user, you add a user age, right? And say the user age is equal to 45, not my real age, by the way, 45 for example. Then we want to then compare the equality of this object, right? We know that actually what we receive is just an object with an age that is 45 in this case, right? This is what we're going to receive. But we want to test that we actually do receive this exact same object when we add the age key in it. So let's write a test then. Therefore, we want to test that should return a user object with age as a key, age as 45 in this case. So I'm going to have my regular anonymous function, ES6 function, and say I expect the user, in this case I can say to be, and have this will definitely fail. I'll tell you why in a second. I can say to be name Clement, age 45. This test will fail because you can see here it failed because to be is used to test primitive type equality, like I said, numbers and strings and booleans. But in this case we're testing primitive type equality, right? And to test primitive type equality, we use to equal. And with that, the test will pass. Definitely, it should pass. But if we do something like 47, of course, the test will fail because it's expected 45. You can see here in the logs that it expected the age to be 45, but it got 47, right? You can see it here. But if I change this back, you can see that the test will indeed pass. Awesome. There are other ways to test equality. In this case, without really paying attention to the exact value of, what the user should get. and especially in cases where you do not know if your function or expression will actually give you Clement and 45, but you expect to receive the general structure of name and age, for example. So let's say we want to, let me just quickly take this out and say, we're going to test that should return a user with a name and age key. Let's say we don't want to care what the value of name and age is, but we just want to be sure that it actually returns the name and age key. So we can just expect that the user, in this case, we'll still use to equal, but in this case, we'll say it should be equal to, we're going to use something that we've not used before. Just bear with me. Expect dot object containing. So it should expect user should to equal to an object that contains a key called name, and this name, we should expect this name to equal to a string type, and we expect the age to be equal to a number type. So if we write this test, we'll see that this test, of course, will run successfully. So let's walk through what I've written here. So we're telling Jest to expect this user object here after we have added the age key with a value of 45 to be equal to an object containing two keys, a name and an age. The name, we should expect the name to have a value here that contains a string, and we should expect the age here to have a value here that contains a number. So you can see how deeply we can actually go in with this without even actually knowing what we're meant to actually have as a result of this expression. And note, this expression could be a function imported from a third-party file, and this we'll do very shortly. So, you know, this is just for objects, but I want to go ahead and test array equality, right? So let's say, so I'm just gonna write a comment here, testing array equality. And to test array equality, I'm just gonna write a new test called array equality, right? We dealt with arrays shortly, but we didn't really deal with array equality. We just tested whether a string was in an array. But another way we can do this is, let's say, where we can test array equality is we can say const users is equal to a list of users. In this case, I can say, let's say that list has, I'll make this simple first of all, Clement, my name. Then there will be Sarah, and there is July. These are 3 different people. And we can then say, let's say a new user is added to our app. We just push that user in. That user is called Jacob. So we do users that push Jacob to add Jacob to the end of the array. Then we want to expect that the array should be equal to a brand new array with, you know, Jacob in. So I can expect users to equal, you know, this is something we can definitely do. Clement, Sarah, July, and Jacob. To be again will not work, right? To be will fail because it's to be only compares primitive types, but to equal compares reference types. So as you can see here, this makes sense. Awesome. So another way to do this is we can say expect users in case we don't know, that doesn't entirely mean much, but we can say to equal to expect dot array containing Jacob. Right now we have an array here, and this array contains Jacob, right? This should work. We're just telling Jest to expect an array of users that contains Jacob, but we have to pass in an array here. And this is another new method we've not seen, array containing. We saw object containing previously, but this is array containing Jacob, right? But we can be a little less purposeful about this. We can say expect an array that contains expect.any string. This should also work because this array contains any string. But yeah, you can also really go deep about this. We can say, let me create another constant called user object in array, and this will be a little bit more complex. This will have an object or contain objects that have username Clement, maybe age 12. Then I can copy this object a couple more times, and this will be Sarah, that's 14, and July, that's 25. So in this case, to be sure that let me just write, maybe I'll write it at the bottom then to make this, make chronological sense. Let's write it at the bottom here. Then I can say user object in array dot push. I can push a new object with a name Phil and age 57, and then I can expect user object in array to equal, of course, then this will expect dot array containing, and in this case it'll be an array here that expects an object containing, and this will be an object, and these objects that are in will expect a name that expects a string, so expected any string, and expects the age of that thing to be number, right? So this test should indeed pass when I save, because it's just defining the whole structure of our data structure here. So if anything is wrong with this structure, let's say we have in this case, instead of age, we have year, for example, and we say you can see now that because Phil had age, the test still passed. But if Phil does not have age and it's all year, then it doesn't expect any object here having anything that has to do with year, right? Having anything that have to do with age, I mean to say. So this is just one way to deeply test whatever your code is returning. And we've talked a lot about array equality in this case when we spend too much time on it, but it's important to understand the real basis of this. But let's move on from array equality and then talk about bringing our functions in this case into Jest, for example, importing new functions. And for this, I'm going to actually create a new folder called utils. This doesn't really matter what you call the folder. I'm just calling it utils, just where I keep my functions. And I'll call this one helper.js, for example. So, and now a function has failed. Why did it fail? 1 second. Okay, it still failed, obviously. Let me change this here to age, and it should pass then. Cool. So, yeah. Now I'm gonna go to my helper functions, and I'm gonna write a couple of functions here using regular node.js. The first function here will be I'm just gonna export them and say exports.sum is equal to a b. I'm gonna write a function that is a sum that takes in two values, a and b, two parameters, and then returns a plus b. A very simple function at the end of the day. So I'm gonna come here to the bottom here, And let me just minimize all of these long gibberish tests. And this is normal. You're going to be writing a lot of tests. It's going to be way longer than this, several thousands of lines of code of tests. Of course, you can modularize your test because it makes sense to modularize your test. But in this case, I'm just going to write everything in one file. Then we can bring in a function called sum from helper.js because we want to test the function. So what we will do is we'll say const. Then we're going to require, which is a regular nodejs function to bring in other files in your your code. So I can come in here, move up one file, and then go into utils and helper, and I can bring in the sum function there. So to actually test this sum function to be sure that it actually works, we're just going to write a new describe block. I'm just going to say describe testing imported functions, and we're going to say test sum function should add 2 numbers. So then generally if something adds 2 numbers, then I expect this sum function then that I brought in to take in 2 parameters, say 5 and 3. I think there's a problem. Okay, plus here, you guys probably caught that. So I expect these 2 functions, these 2 parameters, 5 and 3, sum 5, 3 or 5, 4 in this case. Let's make it 5, 3. To be, because this is still this is going to return a primitive type, so we want it to be equal to 8. So this should pass, and as you can see here, sum function should add 2 numbers passed. And this is really powerful. We are able to import other functions and test them in our test file, right? So sum 5 and 3 should be 8. So that way, if there's an error, let's say we're using this same function in another part of the application, if there is an error, say we added a +1 here by mistake, then this will fail. And we can see why it fails, because we can see that we expected to receive 8 from our test, and we received 9. And this will then prompt us, the developers, to go into the helper function, right? Because we have seen that the error is coming from the sum function, and we see, oh, we made a mistake here. Then I will delete the 1, and then our test will indeed pass. Awesome. So let's write a little bit more complex function. For this, I'll just come here and say exports, and I'll write a function to delete user by ID. Delete user by ID. And this function takes in a couple of stuff. It takes in the array of users and the ID of the user, right? Then usually how this works is we return and the array dot filter, and in this case the user we expect the user to have an ID variable, an ID key rather, and the user that ID should not be equal to ID. This is just a filter function that filters anything that has that ID away from the array that we want to delete. So the ID the user we want to delete will take the user away, and then it returns the brand new array. So we want to test that this logic works, and we can actually delete a user from an array of users with IDs, right? We want to delete a particular user from that array of users. So let's come in here and let's write a new test then. So we want to test our delete by ID function should delete a user by their ID, and then I can come in here and I can bring in the delete by ID function, delete by user ID function, and then I can say, okay, then I want to let me just bring in the list of users here, so I don't have to spend a lot of time typing this list of users. Come in here and paste this in. Awesome. So we have our list of users here, Clem, Justin, and Sarah with different ages. And we want to test that we can actually delete a user using the delete by ID function here. So to test that, we'll just say we expect the array of users here, and then the ID we're going to remove. We want to remove the ID called 3, which means we're going to delete Sarah. So we expect, okay, this is wrong. We expect delete user by ID. That takes in an array of users, and we want to delete Sarah 3. Because Sarah has an ID of 3, we pass in 3 here to actually delete Sarah from our array of IDs, and we expect this to return to equal in this case, because we're going to be doing some reference equality here. We expect this to equal a brand new array without Sarah, of course. So we expect this test to pass. So let's save this. So of course the test passed. Delete by ID function should delete a user by their ID, and it indeed deleted the user by the ID. Awesome. So how we're sure that this passed is if we pass in something else here, let's say we'll make 3, it's gonna fail because it's got something different, and it's we put in 3 here or something else here that doesn't make any sense. So this, for sure, by passing 2, we're sure that it's gonna pass perfectly. Awesome. So now let's talk briefly about this thing people always talk about called test-driven development. And in this case, it's basically writing tests before you actually write the code logic. In this case, we wrote the code logic here first initially, which can be good in some instances, but most times people talk about TDD because it gives you this testing mindset to always test your code before you even start writing the code. It sounds upside downsy, but let me show you what I mean. Let's say I want to write a function. In this case, let me just bring this users array out. Of course, bring it out here. Awesome. So let's say I want to write a function that actually finds one user from our list of users here. How we do that, I don't know how to do that yet, but I want to test. I want to test for it. So initially, I'm going to write a test for it, right? And how do I write a test for it? I'll just say test. And this right now, this is done by test-driven development, right? In this case, I'm just going to say, I want to write a test that finds a user from a list of users. Find a user by ID. And then what I want to happen is, let me just write my callback function here. Awesome. And what I want to happen is I want a function. That function does not exist yet, so let me just create that function quickly and bring it in without writing the function logic. So exports find user by ID. And this function, I don't know what it takes. I don't know. I just know that it's a function, right? I'm just going to save this, and I'm going to bring it in to my new file. I don't know what it takes. I don't know what it does, but I'm going to think about that when I'm writing my test, right? And I want to expect find user by ID, which is my function here, to obviously, what do I need this function to do? I need to have the array, the users array, and I need to give it the ID, I think, right? I need to give it the ID that I want it to delete. Let's say I want to delete Sarah. I want to find, not delete, I want to find Sarah from this array as a test. I'm going to pass in the ID of 3, or in this case, I'm going to find a different person. I'm going to find Justin, which has an ID of 2. So I'm going to pass 2. So I expect this function, right, to equal, this expects this expectation object to equal Justin, right? So let me just paste in Justin in my object here. So I expect this to equal to Justin, right? And if I save this, of course it's gonna fail, right? Because I have not written anything. I'm expecting it to bring out Justin, but I received undefined because yes, indeed, this my find by user function doesn't return anything. It's undefined, essentially. So how do I make this work for me? Well, the first way is I go to my function and I start writing to be able to get this required result. So yeah, that way I know that I've written my tests already for my function, and this function, the function I'm going to write could be more complex than this, but you know, I'm going to write based on what I think the function should do. I'm going to write my test first, then I'll write my function at the end of the day. So this is going to take in an array according to what I said, an array of users, and it's going to take in the ID, and then I want this to return the user from the array, right? So thinking logically, this should return array dot, and there's this function called find, this method called find for arrays. So it takes in a function that has the object that we're looking for. Then the object should have an ID property, of course, and this should be equal to the ID, right? So in the end, this should then all get passed. Awesome. So we've written 14 tests and they're all passed. So this is a way to write it. But you know, obviously, sometimes we should test for failure, and we should expect failure in our code. So one way to avoid failure in the first place is to, you know, pass in default values in arguments. So I'm passing a default array in the array argument, and I'm going to pass a default string in the string argument to prevent any form of failure, right? So you can see the test will pass. So I want to also test for failure. So how do I test for failure? In this case, usually when you try to find something that does not exist, let me just test for that, right? I want to see what I get. Find by user. I should expect users and 10, right, to give me null, right? So I expect this to be null. I think this is what I'm gonna get. I'm not sure. Let's just check. Oh, I failed. Okay, so in this case, it doesn't give you null. It actually gives you undefined, right? So let's see. Let's change this to be undefined. So users 10 should actually give you undefined because, you know, it doesn't exist at the end of the day. So because the ID does not exist, it's going to return undefined. Cool. So this is just a way to, you know, test failures as well, right? So you can say another thing you can do is to say no, I'll leave that for later. I don't want to go too deep into this so that I don't you know, overstay my welcome in this video. I'm already spending a lot of time, but you know, this just gives you, you know, an idea of how powerful, you know, these methods are, especially doing test-driven development, right? In this case, writing the test before writing the function, because that way you're always having a mindset that things could fail. So you could write an extensive amount of tests here, right? An extensive amount of tests, and then you expect different things to happen. You can expect the user length, like in this case of the delete, you can expect the user length to be something. I can say that, okay, I want to expect, you know, delete user by ID users 3 dot length, right? In this case, to be since it was 3 before, it should be 2, and then the test is going to pass. But if your deletion process actually did fail, and let's say you passed in 2, let's say we didn't delete it, and let's say, I don't know, let's say in this case we're just returning the array. Let me not go too deep into that, but let me go deep. I was like going deep. It makes sense to me. And if I take away this previous expectation, We know that this is going to fail. It's going to fail because we expected the length to be 2, but it did not delete any array, right? As seen by what I did here. I just returned the array. I didn't really delete anything. So this way you can easily debug functions by writing multiple tests and making sure that that function actually is returning what we needed to return. So with that, I'm going to move on to another part that doesn't entirely involve testing, but it just involves preparations before and after the test. So let's say we're not gonna do this in our testing crash course, but let's say we want to initialize a database or a sort of subscribe to some service or some API before we want to start the test, or unsubscribe from an API or something, or a service or a database when we finish running all the tests. Or maybe we want to populate a database before the test and depopulate that database after the test, right? That makes sense. So there are certain methods to do that. In this case, we have about 4 major methods. The first method, or the first function, in this case I'm going to cover, is before each. So before each is going to run before every single test that you see here. Every single test. Not every single expectation, but every single test function. It's going this before each function, the callback function inside of before each is going to run. And to test that, I'm going to console.log running before each test. We have 14 tests, so we expect this to log 14 times. So we can see that we have this logging 14 times. I'm not going to count it, but you can just take my word for it that it's going to log for 14 times. And there's another one called after each, right? This runs after each test, as you'd have probably guessed. So as you can see here, it's going to run 14 times as well. And you can see one ran before the test, this one ran after the test, before, after, 28 logs all in one. Cool. So this returns after all tests. Then there's the other one, before all, which takes in a callback function, and this runs before all tests. So this runs once, right, before every single test. Let's save this. So this runs first. That's the hierarchy. Before all runs first, then before each runs, and then after each runs. So let me just make this make sense by putting before all before everything. It doesn't really matter the position of this in your code. I'm just changing my position just so it makes sense to you, the viewer. So before all runs first, then before each, then after each. Then the final one is after all. Console.log running after all tests have run. So if you scroll down to the bottom, we see that we see finally this log running after all tests have run. Cool. And as I said before, there's a lot of advantages with this. Let's say you want to say let user data, for example, equal an empty array initially. Let's just say we want to populate a database before all tests, and we say user data is now equal to an array that has Clement and Sarah, right? Then after all the tests, we want to say user data is now equal to, nothing again. In this case, we are populating this user data before all tests so that we can have access to them during our tests. And that makes sense when you want to make use of certain database values in like a development database structure to use certain values in the database that you communicate with. And when you're done running the tests, it can then delete all those data from the database, and then you have clean data again. I think that makes a lot of sense. Before each can also do something similar, maybe connect to some API or some Stripe service or something different, right? And then maybe after each, you can do some cleanup, right? After each generally is used for cleanup operations like unsubscribing or removing yourself from a database connection or whatever. After all and after each, handle that part of things. So let me just log out this user data before and after population. So okay, just log user data here to make things clearer, and then logging user data after all tests. So I'm logging once before I run the login user data before all functions. Then when before all is called, I'm also logging user data, and I'm logging it again after all the tests. So let's test this out. So before all functions, I see I have an empty array. Then runs before all test runs, and then I have a populated array, then which is being used for every single test that have passed, by the way. And then after all the tests have run, then I clean up and I delete the user data from the user array here, which could represent your user database in the real world application. So awesome. We've done quite a lot in this video. It went on for a very long time, but we were able to fully, to an extent, handle everything that we need to know about Jest and unit testing. In the future video, I'll be talking about integration testing and then end-to-end testing with one of my favorites packages of all, Puppeteer.js. I hope to see you guys then. Thank you guys for, if you stayed this long with me, you're a real senior. And I congratulate you for staying along this ride with me. And please don't forget to leave a like and subscribe, because that really helps in my recommendations and stuff. So with that, I say goodbye, guys.